Like, who here knows what vibe coding is? Okay, good. Who tried vibe coding? Okay, most people, that's good. And who actually released it to production and are now serving real customers? 1, 2, 3, ish. Cool. So it's exactly that gap that I want to talk about and address. Like, what are the things that are really cool about vibe coding now? Where do they break and what are the limitations, and especially why? And what can we do about that? Like, because as we're seeing, like the hype is so much ahead of the actual practical use cases. And so, just a little bit about me. I was primarily a researcher in AI and compilers at Oxford. I was basically inventing new languages which bridge basically machine learning and humans being able to like do stuff very, very quickly and effectively. I went to work at Facebook where I was doing machine learning and machine learning and some backend engineering. Basically, I was working on the friend suggestion algorithms. So whenever things pop up, like these are the people you might know, I was helping improve those. Very, very fun. And then, I started a new company, sold it to Twitter. Now we're known as Twitter Communities. And then Elon Musk happened. So all of us left. And that's when I jumped full on Sutro. And in one sentence, we're trying to basically merge AI and no code. Like how to create like environments where you can actually vibe code your way to a solution in a way that's actually introspectable, understandable. It doesn't force you to go back to have to read code. So that's kind of where we're trying to go. And it's really that area which I want to share. So I want to make it much less about whatever this is Sutro, blah, blah, blah. I want to talk much more about like why is it so hard to merge the two? So let's start with some of the basics. This is the tweet which coined the term vibe coding, Andrej Karpathy, amazing researcher. And he described it as, there's a new kind of coding I call vibe coding, where you fully give into the vibes and forget that the code even exists. And so the original idea really was that you just like talk, and just completely rely on the AI to build everything for you. And so all these people who are now using Cursor or something as a little bit of a type ahead and meticulously like read every line, they're not doing vibe coding. True vibe coding is you literally fully trust the AI to go build stuff for you. The beauty with coding in general and why coding itself is so fun is that you get a fantastic feedback loop. Like you're solving some puzzles, you're writing some code, and then you run it, and then it like works or doesn't. You get this like feedback loop, these dopamine hits from things working, and that's what makes. That's why so many engineers are used to this like state of flow and really enjoy their jobs. And no code does something similar, where you still build stuff from building blocks. You like place building block after building block, and you slowly see how it all comes together. Again, very, very rewarding job. And what vibe coding does, it puts that onto massive steroids. So like you type in something, immediately see something working. It's like, wow, that's so cool. And then you can just like make it like change stuff and just like iterates for you. And it's just like so rewarding. Well, until it isn't, right? Like with coding, like you may have some bugs and it takes you ages to like find them and actually fix them, but there's like always a way to get there. When you're doing no code, usually you will find a way to like around certain problems. You find your workarounds and all of that. So there's like always a way. But the problem with vibe coding is like it works until it like really doesn't. Like as fast as it created something, it will break. And then it gives you like almost no way to actually go find and solve those problems without actually having to go back to reading code, which like completely spoils the whole idea of vibe coding. So why is that, and what's happening underneath the hood? So when you're building software, especially when you code, there's like so many assumptions and things which you need to go into building software. Like there's so many like small things like whatever, data seeding, rate limiting rule, caching strategy, schema migration, whatever, tons and tons of stuff. And when you're building software, when you're writing code, you're basically taking these one by one and like layering them onto each other line by line of code. So you're taking all of these assumptions and decisions which you need to make along the way, and you kind of carefully layer them in block by block. Now, what no code does, it instead of having to put little assumptions line by line, you have much bigger chunks. And so instead of making 20 different decisions about a particular component, whatever, like how checkmark works, or how whatever text input component works, instead you just like pick from several different options for the text input. And what that means is two things. Number one, suddenly you don't have to make like 50 decisions and carefully layer them together. Instead, you're making way fewer at a time and putting in logical building blocks and putting in the visual building blocks. The second thing which it allows you to do, which I really liked in the previous press, was that it makes things much more introspectable and understandable. Like the only way to double check pieces of code and assumptions in code is to actually read pieces of code. But in order to check stuff in no code, you can like review these logical flows, you can review the way your no code like app was actually put together and like the structure of how it comes together. So it both decreases the number of assumptions and decisions you need to make, and it is way more introspectable. Now, what vibe coding does, it like ignores most assumptions. LLMs and machine learning in general, but especially LLMs, are optimized to produce something that looks great. They're trained to produce, whether it's text or images, something that is like what you would expect as a human. So when you tell it, research this topic or something, including references and I don't know what, very often the references are all made up. Right? But in the first moment you're like, wow, this is so cool. It produced an entire research for me. There was even this funny case where there was a lawyer which got his case written up by LLM and the research done by an LLM. It turns out that the case he was quoting was all made up. Right? And the same thing is happening with vibe coding. Like, you get it to build something, and your initial impression is like, whoa, this is so cool. Like, this top layer is actually quite pretty. But when you look under the hood, it missed a bunch of requirements, or it just made really simplifying assumptions, and it doesn't even remember it made those assumptions. And the way these building blocks come together is just like really weird. Like, it really prefers adding new code rather than changing existing code. So it like just keeps blobbing on, bolting on more and more stuff here and there. And so as a result, like this is, we randomly tried this out like a couple of weeks back for the purpose of putting together this presentation. We got one of the popular vibe coding tools to build as a CRM. It landed us on this, and I was like, wow, that's super cool. That's such a cool CRM. And I was like, let's see what it can do. And I clicked on like deals, and it's like, oh, not working. And if even something so on the surface is not working, how much more stuff under the hood isn't? And then we went to Twitter and we're like, well, what are people's experiences? And it's like, this is the example that Nick mentioned as well, which is like he built his entire thing in Cursor, and then he was like, this is a really cool tweet, it's like, random things are happening, maxed out usage on API keys, people bypassing the subscription, creating random shit on DB. Right? And this is just like moments after releasing. Or there's this guy, he went a little bit viral, Daniel Azaria, really cool guy. He, in his lunch break, looked at the list of top released lovable apps and hacked all of them. He literally hacked like the top 15 in his 47-minute lunch break. Or, poor guy. This guy released his thing and the vibe-coded thing got into a loop, like a thinking loop, and it ate $120,000 of Firebase compute. So like, there's so much stuff which doesn't work, and you don't even have a nice way of checking that it doesn't work. And so here's the question, like, what can we do about that? And I claim there are three principles or three main areas to focus on to fix this. Number one is really understand requirements, because if you don't understand the customer requirements, whatever you build will probably not be very aligned with what the user wanted. Then there's the actual translation from those requirements into actually built apps. And finally, there needs to be a suite of tools to allow you to verify that the solution actually solves your requirements. Now, how do we do that? What I claim is a very, very good way forward is verifiable building blocks. In other words, gather requirements, many methodologies to do that, but like gather the requirements in a slightly more rigorous way, and then bundle them together, and then match those bundles against existing building blocks, or if there's nothing existing, then replace it with, or build a new piece of code or a new building block. And what that does is that suddenly every single block you have, you can double check what requirements it solves, and you can actually have like an overview of which requirements are being satisfied or less satisfied. And so it will actually look like, you can almost imagine, like you have a lot of building blocks put together, and each one of those like maps to the set of requirements, some places from an existing library, some from like newly built, and you have the ability to double check all of that. And suddenly, when it's a smart enough tool, it can give you various guarantees. You can guarantee stuff like security. You can guarantee stuff like HIPAA compliance and all these kind of cool things. But see what you did there. See what I did there. Like this is exactly what I was showing you here when it gets to no code. I strongly believe that to do this properly, we cannot just be layering like line by line pieces of code. Like there's no way to really introspect that, and it's really, really hard to match that with the actual requirements piece by piece. And so a much better strategy, in my opinion, is building stuff from these predefined or additional building blocks. So this means like logical flows, this means pieces of UI. And so I strongly believe like the future is in the direction of no code meeting AI. And this is exactly why. Now, there's a remaining challenge here. We've solved the verifiability through no code, but there's still the question of how do we get from understanding requirements and translate into a verifiable solution. Like how do we make AI understand this and work with this? And that's when we get to one other problem, which is like how can we merge those worlds? And so I like to call this the future of the space more like vibe no coding. like vibe yourself through building stuff in no code so that you can actually combine like the prompting and the vibing with actual like visual editing and visual verification. Or actually, I would go even further. If you include into it also like manipulating and gathering requirements and all of that, I would actually go as far as calling it vibe engineering. And I think vibe engineering will have a lot of no code in it. So, the trouble is that the two worlds don't seem to mix very well. Like we're 3 years into the AI revolution, and we still don't have a proper no-code vibe coding tool. Like how come we have like the bolts and lovables of the world, which just generates stuff for you in code, and you can just like prompt them and it builds stuff, and all of the existing no-code tools are having massive trouble actually integrating AI properly. Like yes, you see some baby steps happening, some like early versions, some bits and pieces working, but like it's nowhere near what you can do with like a bolt or a lovable. Why? And this is where my hypothesis or my thesis is that fundamentally LLMs don't get it. Like machine learning and LLMs now as well are very good at what they were trained on, so the data that existed, that was fed to them, i.e. all of internet, or things which are derivable from the things that were fed to them. But if you think about it, well, there is so much code out there on the internet, and the LLMs could learn a lot about code and what decent code looks like. There's actually very little on the internet about how we compose no-code apps. Right? There isn't a huge repository of videos of someone dragging and dropping stuff, right? There isn't really nice structured ways of representing that whole process either. And so it's actually surprisingly difficult for the LLMs to understand and get used to a no-code tool. Even further, and what both no-code and vibe coding tools have a problem with, is that LLMs actually don't understand requirements. Like think about it, like we don't have a standard way of representing requirements. Like each of us, we either have some like spreadsheets or some like specialized tools for that, or just some Notion docs, or some people just have like their interviews with the clients, and then they compose everything in our heads to then translate that into the actions which I need to take to build out this no-code app, or translate that into how I should go about actually coding something. And so there's actually very little on the internet about requirements in a structured way and how they come together to form a solution. And so I am not that surprised that LLMs are not very good at that. And so what is the answer to that, and how to solve this problem? It's actually to create building blocks which are not only verifiable, but also understandable. What I mean by that is that whether a human or an LLM can look at the representation of all of this thing and understand what is actually happening. So if you take like some of the existing no-code tools and like actually export your app into a JSON or something, I don't know how many of you tried, it's terrible. Like that thing is like a big pile of stuff which no one understands. I don't think anyone understands what's happening in some of these config files. How can you expect the AI to understand any of that either? And if you cannot feed it properly, the dragging and dropping actions and these replays, like, how are you going to teach the AI? And that's why many of the no-code companies are trying to figure out like internal representations and like to teach the AI how to use those building blocks. However, my claim, especially having researched compilers and languages before, is that it's very, very hard to bolt that on to an existing no-code system. Like these building blocks need to be built from ground up in a way that is actually very intuitive and very understandable, whether to a human or an LLM. And so that's kind of exactly what we're trying to do at Sutro. Like kind of compose this together. And now, like, I was questioning whether I want to give a demo or not because I don't really want to turn this into like, hey, everyone use Sutro. No, I just want to show you like an example of how this could potentially be done. Again, I'm not claiming I figured it all out or that this is going to work best and we're going to win or something. I'm just going to show you like an example of what is working with requirements and mapping that to like useful building blocks could look like. So, bit of a demo. So this is what Sutro right now looks like. We're going to launch in a couple of days or maybe weeks, depending on how much coffee I drink. So you go, ignore the some of the visuals and errors. Like this is running on my machine, and I've just made some changes earlier today. So what you see is that it starts doing basically the product manager's job, where it's trying to really understand like what are the jobs to be done, descriptions, do a little bit of user journey mapping and these kind of things. You could imagine like it's stopping at this point, like checking with you whether this is what you actually want to be doing, whether this matches your expectations and requirements. You can add more, change things around. And then it like builds the structure, the domain model, the UI. This takes currently like 3 to 7 minutes, and I don't have 3 to 7 minutes, so I'll skip to somewhere where I've done it with the exact same prompt. And it starts looking like this. Like it really starts like outlining the different requirements and what it really needs to do, and starts clustering them into areas of like pages and areas of logic, so that suddenly you can map these things almost one-to-one with the particular features and the particular things which you see on the screen. And you could almost imagine like coming here and just editing these requirements or changing them around, and we'll just go and under the hood, go change the actual app just based on that. So rather than you having to do a global whatever, you know that thing there, can you change it in this particular way? Like, no, actually like go back to what the requirements were and just keep iterating and adjusting on them. Or go all the way like top level and edit the actual like high level spec and definition. Plus, it then merges well with the data, and so you see the various like database pieces. You can query about those as well. Basically, in like a fairly like integrated, like batteries included kind of environment. And I strongly believe like this is the kind of environment where the AI can actually understand really what's happening. I don't think it works well if you have like a separate database somewhere completely else for it to be building against to start with. Of course, You can plug in your existing databases and stuff like that, and give it a bit more explanation and understanding. Now, the preview itself, I just broke, unfortunately. So I'll show you what it looks like when I don't break it. It looks a little bit like this. This is an earlier iteration. So it actually composes like the dashboard against the particular requirements which it gathered for the dashboard view itself. So again, I really don't want to turn this into like a whatever everyone uses Sutro or something, but you see like how it could all approximately nicely come together with working rigorously with the requirements, with a very tight coupling with what the requirements actually were, so that the output we can make sure works against all of those requirements. And not just produce this flimsy like layer on top of something looking good, but not actually deeply working under the hood. And we're finding that this approach works pretty well, but you can judge for yourself in a couple of weeks' time. Why am I talking about all of this? Mostly because like I strongly believe like this is the future. Like if you look back to like 1950s, like doing like automating meant knowing how to do hardware and how to solder electric circuits. And then we invented software in 1960. Suddenly, like building automations and building stuff actually meant you need to know like assembly or something. You still needed to know what's happening in the hardware, but you no longer had to solder. And then 30 years later, we evolved into these algorithm-level environments like JavaScript, Python, where you no longer have to think about the hardware. You can really start thinking just about the pure algorithms. But I believe we're now entering a stage where we can finally not have to bother with thinking about particular algorithms, but really start thinking in terms of product fundamentals. And like that is the level of abstraction on which these building blocks should be, so that you can build it in a way that really makes sense on that level of abstraction. And so why I think it's relevant for no-code, I think that people in the no-code world are the best positioned to make best use of this kind of revolution. There are a lot of engineers who are like, no-code, but like it's going to really hit them, right? Like the same way as we used to have all these engineers who were like, oh, if you don't know how the processor works, how can you write code? No, it will really hit them. And they spend so much time like honing on the actual skill of crafting these algorithms, while the people in no-code are best trained in what really will matter. And that is like really understanding and working with the requirements and thinking on the level of product fundamentals. Good. That's everything. I hope that got across something interesting.